Hello, my name is Eric Williams, and welcome to the latest edition of the UCS Tech Talk series. The goal today is we're going to talk about demystifying monitoring for UCS Manager and Standalone C-Series rack mount servers. I want to introduce my panelists today, and we have two other TMEs besides myself. I'm Eric Williams. I'm a technical marketing engineer for Cisco. Jeff, can you go ahead and introduce yourself?
Hi, my name is Jeff Foster. I'm a technical marketing engineer focused on C-Series servers here at Cisco.
All right, great. And Jason Shaw, can you introduce yourself?
And Jason Shaw, also a technical marketing engineer with Cisco.
That's great. So let's go ahead and get started. I'll go ahead and, the objective of today is to really talk about managing your C-Series servers, monitoring them well as your servers managed by UCSM, so those blades and rack mount servers that we have. I want to start off a little bit today to talk about, what are the interfaces that you have to manage your servers. And the interfaces are very similar no matter if it's the server is managed by UCSM or managed standalone. So we have a couple different types of interfaces. We have read-only interfaces into monitoring the servers as well as read-write. So let's start off with the read-only interfaces. These are interfaces like Syslog or SNMP or cut-through interfaces like IPMI, serial overland, and KVM. So when I say cut-through interfaces, those interfaces are really focused at cutting through the management plane and being able to talk to that server directly. So like with IPMI, you can talk directly to the server to power the server on, power the server off, get sensor details, etc. And serial overland, you can use that serial port over LAN to be able to get information from the console and such, as well as your standard KVM, keyboard, video, mouse. Today, we're really not going to talk about the cut-through interfaces as much. We're going to talk about some of the read-only interfaces like Syslog, being able to send the messages, faults, of audit logs, events to a remote Syslog server so you can parse it and have those records stored long-term, as well as SNMP, so just traditional SNMP through traps, informs, and gets. The read-write interfaces that we have, those are considered ones that you can make a configuration change. With both standalone rack mount servers and integrated managed servers by UCSM, SNMP is only a read-only interface. You can only do gets and traps and such. With the read-write interfaces, that allows you to make configuration changes and make changes to your BIOS, your boot order, your VLANs, etc. And those interfaces are our XML API, our CLI, and our Web GUI. So Web GUI, mainly for our SIMC. We have a Java GUI for UCS Manager that will be able to manage and configure your, all of your fabric interconnects, chassis, and whatnot. The API is really used for monitoring, for configuration, and inventory. So, in regard to this particular session, you can fully configure a server managed by UCSM, its networking configuration, boot order, BIOS, as well as with C-Series, you can do very similar items as well. There's a couple of different ways that you can monitor systems. Today we can monitor things through SNMP. It's probably the top two ways to monitor it is kind of a traditional way, the legacy way of monitoring it through SNMP, since we have standard MIBs that are compliant to the RFC standards that can be loaded into most NMS systems. And we'll talk a bit about more how that works later in the session. As well as you can monitor your servers through the XML API. Cisco has management packs that can load inside of things like HP Operations Manager, System Center Orchestrations Manager from Microsoft, or you could write your own to integrate with whatever tool that you use. You can use Perl, Python, PowerShell, whatever language that you would prefer to write. So I want to transition to talk a little bit about the internals of how things inside of UCS Manager and C-Series servers work. So Jason, I'd like to talk to you a little bit about how UCS Manager works really under the covers. What are the components that make up UCS Manager that people may not know about?
Sure. Well, Well, for one, the UCS Manager has a data management engine, and it's really the heart of the system. Some might even equate this to almost a queen bee in a sense. It's a central area that basically controls the whole system. There's an XML database that's maintained, and inside this database we house all the logical configuration data, so things like your identifier pools, your policies, your templates for how you access the network in the SAN, service profiles, VLANs, vSANs, those types of things. We also have physical configuration inside this database as well, so components like your blades, your I/O modules, chassis, fabric interconnects, and such. And then certainly it also maintains all the health and state of all of these components. You know, anything from faults and alerts all the way to what we call finite state machine transitions. When tasks are being run in the system and states are changing, we get that state back as well, almost in real time.
So really, it's the heart and soul, the brain of UCS, where it's basically telling all of the different elements what to do and whatnot. Correct?
Correct. It's running the show. Yep. Now the next piece that again works right along with the data management engine are application gateways, or AGs as we refer to them. And with the data management engine being the queen bee, you can think of the application AGs or application gateways or AGs as the worker bees. So, and they're really software agents that understand how to talk to the hardware components, and we refer to those hardware components as endpoints. And again, your blades, your adapters, your physical components throughout the system. The AGs are going out, talking to our blades, for example, using a lot of standard interfaces, IPMI, system event log, talking to the BMCs of the blades, basically to pull that information and model it in the database. We have AGs for our chassis management controller, which really runs inside our IOM, and again, that lives in the chassis itself. So we're going out to the chassis management controller, getting port statistics, faults, and status on that device. On the IO module, we're getting, I should say, the IOM, we're getting faults and stats. The chassis management controller, we're getting health information, power and cooling as well, how the fans are running, all the sensors that live on the blades inside that chassis. And then the next category would be our fabric interconnects, where we have our NXOS running. We have application gateways that go out and talk to NXOS, get faults and alerts, statistics on the ports, status information as well. And again, all pulled in and put into our model in our XML database. As you plug in new hardware, for example, insert a new I/O module or a blade, there are discovery processes that take place. So all that information is fed in as well through our AGs. We're constantly monitoring the health and state of these endpoints as faults or alerts or relevant information become available. Again, that's placed into that database near real time. Excuse me.
No, that's great. Thanks, Jason. I think it would be great to see. I know that you had a kind of a view of what it really looks like inside of UCSM from a hierarchical perspective. I'd really be understood to understand a little bit more about when faults are shown in UCSM. Are those faults historical, or are those particular faults ones that are present, only when they're active, or is it a historical type of view?
That's one thing that's great, I think, about UCS is we have what we call an active fault log. So that information, again, processed in near real time is real time and not historical data. When I look at the status of a particular blade, for example, I'm seeing faults and alerts relevant to that blade at this time, and not having to go back through historical data to find out sort of the health and state of my objects. Right.
That's a good overview of what elements make up UCS. Let's drill down a little bit more about how a fault condition is raised from when a fault occurs, on an endpoint, and how it gets pulled into, the DME, written to the database and such. It'd be great to go through an example of that.
Yeah, perfect. I actually have a PowerPoint diagram that I'll share out. It's got a great overview that'll walk you through that. Great. So some of the components I talked about just a moment ago, you can see on this slide. We've got the DME in the middle, and it's really the central point where everything is intersecting. You can see the AGs for the blades, the fabric interconnects, the hardware components. We've got the database off to the right. Again, very important. You can see the UCS Manager GUI coming down, talking to the DME. I'm going to go ahead and kick this off, and we'll see.
So a couple things on this one. You've got the GUI and the CLI. I mean, the GUI uses our XML API here. It looks like, and the CLI both talk to the DME. So it really looks like the DME is the central point for everything that you would how you configure that UCS domain. Correct?
Correct. It is the central point, and regardless of your interface type for getting in. So as you said, you can see the UCSM GUI coming in over the XML API. That's got bidirectional communication where we're making basically XML posts into the DME and receiving events back over what we refer to as the event stream. But even off to the left where we have SNMP and Syslog, some of those are bidirectional communication, some of them are one-way. As we have events happening in the system, we can send them out over Syslog or SNMP. They're all coming from the same source in the DME, so it's the same data. And on the SNMP side, you can make standard SNMP gets into the system. They're sort of translated on the way in, and again, the data is coming directly from the DME. So the DME really becomes the single source of information in the system, regardless of the method that you use to talk to it.
So basically, it goes through some sort of translation layer behind this SNMP daemon to do an XML query to the DME, and then translate it back into a SNMP response in that case.
Exactly.
Oh, great.
Yep. And now a couple of examples of how this communication takes place. You may be inside the UCS Manager user interface, configuring and associating a service profile to a blade in the system. And again, through the XML API, documents are sent. I should say through our web server that we have running on the Fabric interconnects. Documents are sent into the XML API, posted in the DME, written into the database, and then the DME, again, sort of the queen bee, if you will, is farming out jobs to the AGs. The AGs are going out and actually talking to the endpoints, the blade in this case highlighted in green. And you may have saw the lines toggling a little bit. There's constant communication in both directions between the AG and the hardware, and again, bringing that information back into the DME and feeding as activities take place. There's information being sent over the event stream. So if you're monitoring with the GUI, you're seeing these tasks process in real time. You're seeing states change in real time.
And so that's really where the FSM states come into play here, when the DME talks to the AG and the AG to the endpoint to make that transition from the current state to the desired state when you make a config change.
Absolutely. Yeah.
Let's go and look at a fault. It'd be great to see how a fault gets raised in the UCSM as well.
Great. So again, here's a fault condition happening on a blade. We've got the blade highlighted in red. The AG, again, constantly monitoring that blade, identifies the fault condition.
It's just using things like IPMI and looking at the cell log to get that information, correct?
Exactly. We leverage standard interfaces available on the x86 infrastructure, IPMI and system event log certainly being two key methods. And as you may have seen, that information gets fed back to the AG, event makes its way back to the DME where it's sort of processed and posted. And then for all your clients, if you will, that you have configured, your UCSM GUI will see that fault in near real time as the event stream data is updated. If you have SNMP configured, if SNMP receivers configured, Syslog server IPs configured, we're sending, again, that same fault data through our translation layer and out through our SNMP or Syslog transports.
And so really, again, the DME is still the single source of truth, again, no matter how you're getting the information.
Exactly.
Oh, great. This is a really good overview. So, Jeff, I'd like to kind of do the same type of thing for a standalone C-Series server. I'd like to understand a bit of background of how the C-Series monitoring has evolved over time throughout the different versions of SimC that we have.
Sure. So with our C-Series servers, we started out by implementing alerting and monitoring solutions through IPMI pet events, so platform event traps and leveraging platform event filters. which are the mechanisms we could use to select which traps were sent. In SIMC, or Cisco Integrated Management Controller, version 1.4, we introduced SNMP v1, v2, and then in version 1.5, we introduced SNMP version 3. We also, in version 1.5 of the SIMC, introduced the concept of a fault engine, which has a very similar look and feel to the DME structure that Jason had described to us just a couple of minutes ago. So we have a design inspired by UCSM, but optimized around a single C-Series server.
So how is that, fault engine and monitoring, similar or different to, to UCSM in a C-Series standalone environment?
Well, let me take a minute here to share my screen where I've got a diagram, so that'll help make it a little bit more clear. So this is a view inside a C-Series server. At the bottom we have the elements within the system. So on the right we have CPU, memory, fans, power supplies, the elements that you would traditionally expect to see in a server, as well as on the left, storage controller and drives. These are communication between the fault engine, which is the new fault aggregation point within the system, and those endpoints are driven through IPMI as well as cell logs, very similar to UCSM. In the case of the storage controller, we actually have a storage daemon that is sitting between the fault engine and the storage controller collecting data. In the event of a fault on a disk, the storage daemon would do a query, notice that there was a fault, and then pass that information along to the fault engine. We support standard interfaces similar to UCSM, so left to right we support SNMP for both SNMP traps as well as SNMP gets. We support Syslog communications out to Syslog servers, as well as bidirectional communication through the XML API. So customers can use one of our integrations or write their own integration that will query the system through the XML API. The other thing I've got captured here on the very right part of the slide is the ability to configure. So we can use the XML API to configure endpoints within the system through sets and gets. So we can do queries as well as setting information there.
So what's the process of a fault getting raised into this particular fault engine? And how is it sent out through the different interfaces northbound out of the SIMC, which the SIMC is the Cisco Integrated Management Controller?
Exactly. So in this case, we've simulated a logical failure for a fan. In this case, IPMI would be, we would be looking at the IPMI sensor values within the fault engine. We would notice that there would be some threshold crossed. In this case, we can say that in the case of a fan failure, the lower fan rotation threshold will have been crossed. At that point, an alert is sent to the fault engine, and that fault engine propagates that fault outside the system through any communication service that's been specified, SNMP, Syslog, or through an XML API listener.
This is great. For customers that have already set up their monitoring, though, for UCSM, what are the additional steps required here? Do they have to start all over again to configure monitoring for standalone C-Series server, or are there some gains that they get if they've already started monitoring UCS Manager managed systems?
There's actually huge gains because we have great consistency between UCSM and C-Series. You'll find that things like our MIBs are consistent across UCSM and C-Series. So for those customers that already have an NMS system with our MIBs compiled and loaded, we'll be able to take advantage of standalone C-Series being able to report into that same system seamlessly and easily. Another example of convergence are fault names and IDs. So customers who have set up rules to look for fault names or IDs and perform some action will be able to leverage that investment already made and start monitoring their C-Series.
So really on the MIB side, the MIBs are identical, they come from the same source, and the faults are all the same, so it really makes it easy. You might have a smaller subset of faults on a standalone rack mount server, but the ones that are relevant to a blade or rack mount managed by UCSM are relevant on the C-Series standalone as well?
Exactly, and I get customers asking all the time what steps they need to take to monitor their C-Series servers where they already have UCS monitored, and I say you just have to really pull that C-Series system into the same environment, and all of the back-end work in the NMS system has been done for you with the MIBs and the consistent fault naming, so it's very, very easy.
And what about the API? I mean, is the API similar to what we have with UCSM, or is it totally different for C-Series?
So much in the same way that we've been inspired by UCSM through the architecture of the fault subsystem, the API is similar. So the model is a smaller model than we have with UCSM, but we're only managing one system. But when you look at things like classes, in the case of faults, the class is the same between UCSM and C-Series. So the API has great consistency with UCSM. So customers who know the model, who understand the process of either setting or configuring endpoints through the API on UCSM will hit the ground running very quickly with our standalone C-Series.
So really, the API is just for a standalone rack mount server is just the elements that are monitoring and managing that actual system. It's not really integrating into the networking elements or the switches like UCSM. It's just whatever's on the sensors on the board and the power supplies and the configuration, the BIOS and boot, correct?
That's exactly correct. So we're looking at this from the standpoint of a single server, and where in UCSM you do have that converged networking within the context of the system. That's something that we don't have in C-Series, but we do monitor all of the endpoints, the boards, the fans within the system.
So you mentioned the API and SNMP. What are the other options that customers have to configure alerting?
So one of the other options that we had in the slide that I shared just a moment ago is remote syslog. So a customer could specify in our C-Series systems up to 2 remote syslog servers, and also indicate the minimum severity that they want to send. So if a customer only wants to receive critical and major alerts, they can set the threshold severity to major and have those sent to a remote or 2 remote syslog servers.
No, that's great. So I think it would be really good to transition now to show how the faults are similar in both UCSM and C-Series server, how the faults show up in the different tools that we've talked about, albeit SNMP, Syslog, or the API with our management packs and whatnot. Jason, I know that you had some stuff prepared to show some videos of how that all works. That'd be great if we can transition to that.
Absolutely. Great. So Jeff and I worked extensively to simulate a few different scenarios. We're actually going to cause a few different fault types in the system, both on a UCS managed C-Series server, showing how the faults propagate to the various types of monitoring tools. SNMP, for example, we've got iReasoning configured with our MIBs. We've got a Syslog server available. We also have a UCS Manager UI, as well as a view in SCOM. So we're going to show this to you from 2 perspectives, the same fault types, and again, propagated from a C-Series managed by UCSM and also a standalone C-Series server. And again, causing the fault and watching how that fault propagates to the various tools that we have available. So our first fault is going to be a fan fault. Now we've caused a particular problem on this fan, and you can see that the fault appears right into UCS Manager with various information, again, right from our DME.
So we've got a couple fan faults that are hitting some speed sensor values, it looks like.
Exactly, and those faults have appeared in UCS Manager. We can see them now hitting our Syslog server. Again, what's important is they're all coming from the same source, so we've got the same information in both areas.
And that looks like the same fault description that you see in UCS Manager that there at the top.
Exactly.
Fault codes, severities, etc.
Yep. Here's our SNMP trap receiver, again receiving the same failure data. And then also, with our system, when you mitigate the fault, these faults will automatically clear, and we'll send clear events as well. You can see the faults clearing on the UCS Manager side. We'll go ahead and acknowledge those. And when we move over to our Syslog server, we should also see the same types of clear events coming in. Again, here they are as we fix the problem with this particular fan. We've got our clear events coming into Syslog. And then lastly, we'll move over to, again, iReasoning and watch our SNMP traps come in.
So this is where we're getting the two different OIDs. We got the first one that showed that the fault was active, and the second one here that we got the faults were cleared.
Exactly. Our .1 OIDs for fault being raised, and our .2 for fault being cleared.
And then everything on the bottom here is all of the variable bindings that we send, and it looks like it's the same data as what we have in UCS Manager as well.
It sure is. So the second fault we're going to invoke is actually removing a power supply cable. So here's our fault getting presented into UCS, indicating that our power supply is off and offline. We've got our syslog events for the same data. And then also showing our, our traps coming into iReasoning on the SNMP side. And here are the events clearing in UCS Manager. So we'll acknowledge those, and we'll look at our clear events coming in both on the syslog side and then also on the SNMP side in iReasoning. Again, all common data.
Yeah, everything's that's the DME and the data. What the data is that's in the database there is all again the exact same source of truth and such.
Yep.
And so what you're going to show here, this looks like it's this is a we're going to talk about local disks here as well. This looks like some new features here, I guess. Are we showing some items of what's coming up in the next releases of UCS Manager?
We certainly are. I'm running some new code. Our next 2.2 release. So you'll see some enhanced fault monitoring in real time on this system here. So I've pulled a local disk. I've got an indication that the disk has been removed, that the virtual drive is in a degraded state. And again, I'm going to see that data propagate as well over the other two facilities, both Syslog, as you see here, and then SNMP as well.
So just one quick question on this with local disk versus the other things that you showed. Everything else you showed will work. It works like it does on the current shipping releases, correct? There's nothing different about what we're showing, on the other faults with the power supply and whatnot.
That is a great point. Yep, and it's really just the local disk monitoring features. The third fault that we're raising, where we've got some more detailed information coming through, more detailed status. And here on the clear event, we've got an updated status on the virtual disk. A drive, for example, the newly reinserted drive is rebuilding at this point. And then moving over to Syslog, again, the fault clear and updated status as well. And then moving over to iReasoning for the same data via SNMP. Again, what's really nice is having that common source of data. When we implement a feature, it's available on all of our interfaces. We've even got a UI status that you saw there for the drive actually rebuilding.
Now, we had a question from the audience that asked, would you describe the difference in approach for monitoring C-Series servers that are managed by UCSM versus those that are standalone? So with UCS Manager, the server form factor is basically, it's irrelevant. We monitor and manage servers regardless if it's a rack mount server or a blade the same way. The same processes that we detailed in the previous slides we had and what we were showing here in the video are the same. The standalone rack mount server doesn't have a central point of management like UCS Manager today, so it basically will send traps and alerts on its own to any NMS system. So each of those rack mount servers are autonomously managed alone. When they're connected into the fabric interconnects through the FEXs and UCSM, that DME and those AGs are monitoring a C-Series server no different than it monitors a blade. So, and that in the diagram that Jason showed earlier, we kind of had AG N, and so we didn't show all of the application gateways that are present, just the ones for that particular example. There are AGs that will talk to rack mount servers as well. And then a second question, I'm going to ask you this one, Jeff, is we had questions about supporting metrics in C-Series, such as the stats_cur call. So stats_cur is a class that basically gets you all of the current statistics in UCSM. What are things like that? What's the roadmap for getting statistics in C-Series servers?
Sure. So we do have some statistics data available today for things like thermal sensors on the system board and various sensor endpoints that we are monitoring and presenting through the XML API. We are going to continue to expand the number of sensor values that we're monitoring and extend the statistical reporting that we have through the XML API to include more and more of those same capabilities that we have on UCSM today. So a good way to understand exactly what's being monitored and presented through the XML API is to use Visore, our model browser, and I'll talk a little bit about that in an upcoming section that I have.
Yeah, one other comment that I'll add to that as well about metrics in C-Series versus UCS Manager is that C-Series, when we get the statistics, we're actually querying them in real time, where UCS Manager is doing that for you and doing a collection every 30, 60 seconds or 2 minutes. So there won't be a stats_cur query for standalone C, because when you query the elements that you're wanting to get data from, you're querying them in real time. So. So Jeff, I think it'd be great to show a similar view of what faults come up in the different interfaces in C-Series. So it'd be great to transition to that.
Yeah, so I've got a video here that I'd like to share, and as you'll notice, the setup is very similar to the setup that Jason had shown earlier, where we have a C-Series server that is integrated, as well as now a standalone C-Series server. So in this case, we're going to look at the standalone C-Series server, and to the question that came in just a moment ago, you'll see some of the commonality and consistency between the alerts on the standalone versus the C-Series server that's integrated into UCSM. So for consistency, we generated the same fault. So in this case, we generated a fan fault, and it comes into the Cisco Integrated Management Controller. And if we look down at Syslog, you can see here that Syslog reported fan failure in the same context that we had for UCSM. And in iReasoning, we have the OID for the notification of a fault for the fan. And then we've cleared that failure, and you can see it automatically is dropped from the fault engine table. We get the cleared notification in Syslog, and then we get the cleared notification through that second OID with the .2 at the end in our SNMP browser.
So it's a good time for a question that we had from the audience.
Sure.
What makes that the faults be all the same across all the different interfaces in standalone C, where we have the SIM translation layer, that abstraction layer in UCS Manager? What's the element that makes that all the faults be the same across the different interfaces?
Sure. So as I shared in the diagram earlier, we have a clearinghouse within the system that is the fault engine. And that fault engine is converting the sensor value data that it receives from IPMI or from storage D. It's doing a lookup and conversion, and then sending that data out, propagating that data to monitoring tools, Syslog, SNMP, XML API in that same format. And we use the same format specifically from UCSM. We're using the same source files, we're using the same nibs, so we've got great commonality across C-Series and UCSM for that reason. But it's the fault engine under the covers that's providing us that value. So I'm going to let this video continue to run here, where we can highlight the commonality between Standalone C-Series and UCSM. So in this case, we have a power supply. We're going to go ahead, and you see that we've lost redundancy, and we have a fault on a specific power supply. So in that case, we actually generated multiple faults because there are multiple conditions that were impacted, or multiple conditions that were raised with the faulting of a single component. The last example we're going to provide here is where we've physically removed a disk. So in this case, storage D is polling the controller. The controller notices that the drive is missing, reports that back to the fault engine, and the fault engine propagates the alert. And then we reinsert the disk and let that rebuild. So you can see here that goes to warning, and when the rebuild is complete, that warning will be cleared as well. So across the board, we have very consistent, and as Eric had mentioned, it doesn't matter if it's a B-Series or a Blade or a C-Series again on UCSM, or if it's a standalone C-Series. The information that we get is very consistent. So what I'm going to show you here is Visore. This is our XML API model browser. And we have a class for all of our faults, which is fault inst. So in this case, we're going to log in, and we're going to query that class. And the return, what we're going to see in return is, through the XML API, very consistent data, fault by fault. So if I scroll down, you can see much of the data that we saw in Syslog or SNMP is also available through the XML API. Now in this case, we can plug in a Cisco developed integration. In this case, we have SCOM, System Center Operations Manager, and we can look at our systems, and we can see faults in our systems. All of this information is being pulled through the XML API. In this case, you can see here we have, again, a power issue, and we happen to know that we're going to rectify this, so we can set the resolution state to scheduled. So we're going to go into the data center a little bit later and plug that power back in. So again, this is how we present data through the XML API, both in raw format, and you can see that through Visore. You can actually follow the tree down into different classes or subsystems to interrogate the system. This is a great tool that could be used to look at what statistical data is available. So we had that question earlier. But if you wanted to go understand exactly what information is presented through the XML API, Visore is a very good way to do that. So with that, let's take a look. Eric, you've asked a lot of the questions today. You've been doing monitoring for a long time. So could you explain for us a little bit about how we map faults in UCSM or in SIMC to SNMP traps, the same traps that that Jason and I were just showing in our video?
Yeah, let's talk a little bit about the history of how we've actually created SNMP alerts and such. It goes back to UCS Manager, and when we started developing UCS Manager, we really only had SNMP alerting for the fabric interconnects. The fabric interconnects were basically Nexus 5000 with UCS management software inside of them, and then that UCS management software models the entire configuration of that particular domain. So we've already had the items, all the data that we needed and that we'd want to potentially provide to an end user, but we needed a way to map that from the data that we're already gathering with our UCS management software and provide it into SNMP form. So we really started to focus on developing, a set of MIBs and traps that mimicked and basically used that, again, that same source of data, that XML database, to provide that information. So we developed, we basically added a new tree under the Cisco management MIB subtree, .719, and provided, the first thing we provided with UCS Manager version 1.3 was just basically a set of traps. The first step that we did was basically defining, just a way to query for the fault table, as well as provide traps and informs for all of the faults. So we basically defined two traps, one called CUCS fault active notification. So we showed those in previous screens where we the OIDs that ended in .1, and those are alerts that are sent when a fault is active, meaning a fault is being raised, it has a severity of something like minor, warning, major, or critical, and a fault is occurring. The fault could potentially, go up and down in severity. It could go from minor to major to critical and back down. So it can change severity. It can occur. We track the number of times it's occurred and whatnot. And when it's fault, and when that particular issue is mitigated, then we'll send an appropriate clear notification. And so the reason, there's a couple of approaches with traps that you can take. You can create a trap for every single fault code or condition. And in UCS Manager, it's about 1,400 faults. So we didn't want to create 1,400 OIDs. We would rather just basically dump all of that information into a couple of generic OIDs. And that's really what these are focused at. These are focused on, translating the fault information, which is identical from one fault to another, and basically dumping them into the same variable bindings, which is what you see here. We have, the fault instance. That's the unique instance ID. It's a 32-bit integer number that uniquely identifies this particular instance of a fault. And then we have a lot of other things like the fault code, and that's the actual F0000 number, where zeros can be any integer, that defines the appropriate faults in a particular system. So I mentioned like 350 fault codes. Those are the fault codes that I would recommend you monitor. There's 1,400 faults. There's a lot of different faults. There's about 1,200 faults of type FSM that we really recommend you not worry about, because those are transition events that are more used for debugging. So there's 200 to 300 fault conditions that you really should monitor for. There's a lot of different types. We have a lot of different probable causes, meaning there's firmware upgrades, equipment went offline, there was a power problem, etc. And then the description, that's basically the human readable description of what that particular fault's doing. Meaning is a port up, is a port down? Is it a config failure on a service profile because there's not enough resources? These variable bindings map one-to-one to all of the different elements inside of a fault class as in UCS Manager. And as Jeff has said, we've used the same definition for standalone rack mount servers, the exact elements that you see here for standalone rack mount servers as well, to keep that consistency between managing a C-Series server standalone or managing a blade or a rack mount server inside of UCSM.
This really helps clarify everything that we were looking at in the videos that Jason and I just shared. And if you were to load the SNMP MIBs into a network monitoring system, which MIBs are most important? Can you give us a description tell us a little bit more about the MIBs that we should be focused on?
Yeah, there's a fair number of MIBs that you need to load as prerequisites. So those are standard MIB2 MIBs like SNMP v2 MIBs like the SMI MIB from SNMP v2, the TC MIB, some of the Cisco MIBs for textual conventions and SMI, etc. That list of MIBs, I highly recommend people go and look at our MIB Quick Reference Guide. There are two MIB Quick Reference Guides, one for UCS Manager and one for standalone rack mount servers. And that MIB Quick Reference Guide will tell you, one, where do I go get my MIBs? What are the prerequisite SNMP v2 MIBs that I need to load in my NMS system to monitor both UCS managed and standalone rack mount servers, as well as the MIBs that I need, from Cisco specifically for UCS to monitor both the standalone rack mount servers and UCS managed servers. It will give you the order of what MIBs to load, meaning it'll tell you what's the order you should load the prerequisite MIBs as well as the Cisco MIBs, so that you don't get into any issues of MIB loading or order or issues when you're loading those MIBs. The MIBs, there's 4 MIBs from UCS that are really relevant to monitor, to use for sending alerts. So I'd say there's 2 use cases for our MIBs. One use case, or actually 3 use cases. One is for just monitoring and alerting, understanding what's happening, what faults are occurring in my environment. And there's 4 MIBs you need for that. And they all start with Cisco-Unified-Computing. And the 4 MIBs with that prefix are the parent MIB, so the Cisco Unified Computing MIB. And that basically is the parent MIB that all of the other Cisco Unified Computing MIBs will load as a prerequisite, or need as a prerequisite. We have a textual conventions MIB that basically defines any of the data types that we need specifically to when we send you data. We have a fault MIB that defines the fault table and all the different elements that that can make up a fault. And so that has a definition of the fault table that you can query into a standalone rack mount server or a UCS managed server. And so you can do an SNMP get to get that information, or and alternatively you need to load the notice MIB, which defines our traps, those 2 traps that I showed previously, the .1 trap for the CUCS fault active notif, and then the .2 trap for the CUCS clear notif. That defines the 2 traps it will send you when we raise a fault or clear a fault.
So when we're talking about UCSM, how do I know where an SNMP trap or a Syslog message is going to come from or originate from?
Yeah, so with UCS Manager, each fabric interconnect has its own daemon. So we leverage, if I go back to UCS Manager 1.0 through 1.2, the only SNMP implementation we had was the standard NXOS implementation. So NXOS has its own Syslog and SNMP daemon, and each fabric interconnect that will send out alerts that are related to the port configuration or get information about statistics that are the equivalent of what you would get with a Nexus 5000 switch. So UCS Manager, when it raises those faults into UCSM, those particular, we're using the same daemons that NXOS uses. So we're basically going to send that trap or that query, that that Syslog message via either of the IP addresses on the fabric interconnects. So it's not going to come from your virtual interface, that VIP that you use in UCS managed clustered mode. It's going to come from the source IP is going to be one of those daemons. So you'll need to logically group those together in your network management system to know that FIA or FIB is basically the same logical entity, one of those fabric interconnects.
So we've talked a little bit about SNMP now. Let's switch gears and talk about Syslog a little bit. What's the format of a Syslog message that's sent from UCSM?
So the format of a Syslog message, I'm going to share my desktop here again, and this particular format is relevant for UCS Manager 1.4 and later. So basically, what you'll see on the left, on the top example, you see the date. That's very standard Syslog format. But in the middle, where that's red, green, and purple, that's basically something that we've done that's a little bit unique to how Cisco across the board defines Syslog. So you have a facility code, and then in all of the faults that come from UCS Manager will have %UCSM. So that facility code will allow you to write a filter that says, if I see %UCSM, then we're going to know that comes from a UCS Manager. The dash, the severity is the number, it's the Syslog severity code that we've mapped to. The one thing we have as well is a Syslog guide for UCS Manager that we just released a couple weeks ago, and it talks about how the mapping between Syslog severity and UCS Manager severity gets mapped. I'm not going to talk about that today, but that's another good reference. That Syslog guide is available for you to understand how those mapping works and whatnot. The mnemonic that we have in the area in purple, basically that corresponds to the probable cause element of a fault. And so in this case, in this example, that we have a log capacity issue. If you have a power problem, it will say power problem. If you have a config failure, it will say config failure. So that basically is another good element for you to be able to filter against. So let's say I want to figure out log capacity messages. I just don't really care about those. I can write a rule that will specify if I see that mnemonic, then I'm going to filter that message out. Everything after the colon that you see is just basically is again the fault code, the severity in UCS Manager. Again, that probable cause again, the affected object. So in this case, the blade 7 cell log is getting full. And then after the DN that you see there, or the distinguished name, that path and the XML API of what's happening, that's the normal, everything that starts with log capacity on management controller, etc. That's the description that you would see, in the same description you would see in UCS Manager.
So do you have a list of how UCS Manager severity mappings would map to Syslog severity?
Yeah, that's what I was mentioning before. That's in our Syslog guide that you can go grab that particular mapping. I mean, most things map kind of one-to-one, but there's a couple elements like UCS Manager severity minor faults get mapped to Syslog severity warning, and UCSM major faults get mapped to error, etc.
So in your time focused on monitoring and UCS specifically as well as C-Series, could you talk to us about some of the best practices on filtering, things that you recommend? In fact, we got a question here about this very topic. So there's definitely a lot of interest, but could you share your recommendations here on filtering?
Yeah, so there's a couple different recommendations that I would make. I want to start with, I've talked about it a little bit already. What are the different types of faults that you could have in UCS? So I'm not going to talk about every one. I'm going to talk about the most critical ones and ones that you should care about and not care about. So these are, every fault in UCS Manager is typed, meaning we have one of these fault types defined per fault. My general recommendation for monitoring UCS is twofold. You should monitor all faults that have a severity major or severity critical. So all of those particular faults that do not, keyword not, have a type of FSM. And the reason why I recommend not monitoring and alerting FSM faults are most FSM faults will transition over time and resolve themselves. A good example is if I power on a server, and basically an FSM state change is waiting for that server to power on, and maybe the server has 48 DIMMs and it takes a long time to go through a post. That timeout that the FSM state change is waiting for you to power on, that server to go through post may fail once or twice because the timeout may be smaller than the time it takes the server to go through the memory check phase. So that is a good example of most likely, unless the server is broken, that particular element's going to, resolve itself. So if a particular set of faults that have FSM errors occur, if they do have an issue where you're trying to get through the issue and it does hit the retry limit, what will end up happening is we will raise another fault. Example in this case, if the server if it's going through a server profile association and it can't power on the server, it's going to provide a config failure that the server's profile association faulted because of this FSM issue. So the more severe issue in this case is the server profile can't be associated, and then the FSM one is more for debugging and whatnot. So that's my particular recommendation is to monitor major and critical faults that are not type FSM.
So we got a question that came in asking if you could talk for a moment about a best practice for threshold policies for port monitoring.
So, for port monitoring, I know that we have a white paper that one of our fellow TME, Steve McQuarrie, has written, and we'll make sure that gets posted on communities because he has a really good definition of what to set. What are our recommendations to set to create those threshold alerts for network utilization. That's a whole nother tech talk in itself. So I don't want. I would like to take that one offline, and let's create a discussion on communities to talk further about that. So whoever has asked that question, I would recommend you go to communities. Let's get a discussion going on that, and I'll bring our fellow TMEs like Steve McQuarrie in to talk about that.
Perfect. To keep the conversation going even between these events. That's a great point. Now, as far as if I wanted to get environmental information, is that information collected via SNMP? How would I get environmental data through SNMP, and is it available?
Yeah, so that's another great question. From a statistics perspective in UCS Manager, all of the statistics we get are available through both the XML API and SNMP gets. So you can get information about the statistics for ports, the on the Fabric Interconnect, the ports, the border ports going northbound, the server ports going southbound, both for LAN and SAN. You can get statistics at the adapter level. You can get statistics for power and cooling as well. So all of those things are available through the SNMP and through the XML API. And alternatively, in UCS Manager, we only store a very short amount of time and data, and that data with UCS Central is being mined. We can have it being mined for the matter of months to years in a database there as well. So if you need to get longer trend data, I would recommend you get that information up to Central, because that's a great way to be able to do trending and such.
And one last question here on best practices, and I want to take a moment and ask a question about C-Series specifically. So are there any best practices? We have a number of different technologies that we've introduced over time. Is there any best practices about what to use or not to use with respect to C-Series?
So a C-Series, since it's a lot less, there is not a finite state machine. It's a lot more simplistic of an implementation. The faults that get raised with C-Series are all really relevant. Those are all conditions that are going to occur, that could potentially impact the availability of your server and those types of things.
Perfect. Thank you so much. So that's some great insight and recommendations around best practices, both for UCSM and our rack mount C-Series servers.
Yeah, there's one other question I did see, about the VIF path down events. Yeah, that is a true event, and that's an area that we're working on figuring out better ways to alert on. The VIF, for those who aren't familiar, there's a VIF as a virtual interface that is created in the Fabric and UCS Manager between an adapter and throughout the Fabric. That, if a server is to go down, the VIF, you will get VIF errors and whatnot on that particular adapter. One thing that I would recommend you do if you're doing maintenance on a server is to enable fault suppression. So fault suppression was something we added in UCS Manager 2.1, and that will allow you to filter out events if you know you're going to do maintenance. If you're going to shut down a server, add more memory, change an adapter because it's broken, etc., I highly recommend you turn on fault suppression on that blade or rack mount server inside of UCS Manager to reduce the amount of noise that you get. And then once that event change event is over, then you can then turn the suppression off. So Jeff, I think we got just a little bit more here. We wanted to talk through. Can you tell us a little bit about some of the developed monitoring solutions that are available today that Cisco has developed?
Sure. Out on our Cisco community site, so communities.cisco.com/UCS, we have a space dedicated to our integrations, and we've got a number of Cisco-developed integrations for Microsoft System Center, both for UCSM and C-Series that include PowerShell module called PowerTool, Operations Manager, Management Pack, Orchestrator Pack, System Center Virtual Machine Manager. So there's a lot of integrations that we have that work together through the XML API. And we also have integrations that leverage the XML API for HP, HPOM and HPOO.
That's great. And what about anything with SNMP? What have we done with SNMP?
So really, we publish a portfolio of MIB2 compliant MIB definitions, and we've tested a number of different NMS solutions internally, including Cisco DCNM, a number of HP solutions, Nagios, SNMPD, iReasoning, which we shared with you today, SimpleWeb. So we have customers that come to us talking about other monitoring SNMP solutions that they're using. If your NMS system accepts MIB2 compliant MIBs, then feel free to load or compile those and leverage whatever you're using internally today.
Well, that's great. So I want to wrap up here and talk about some resources that we have available for both standalone rack mount servers and UCS Manager. A couple things that I want to key on are our MIB quick reference guides. We have those links are available in the event here. Those MIB quick reference guides are really great to tell you, what is the bare minimum you need to do alerting, what are some of the recommendations to do monitoring for using those statistics, what MIBs you would need to load, and what are the tables you would need to query in those MIBs to get the data. Secondly, we have fault and error reference guides for both C-Series and UCS Manager that defines all of the alerts and fault conditions that would occur inside of our UCS servers, either managed by UCSM or C-Series, as well as the MIB quick reference guides point to where to download our MIBs for C-Series and UCS Manager. Again, we have a newer doc as well for Syslog, so some recommendations on monitoring Syslog for UCS Manager. Again, I would like to thank everyone that joined. Again, we have another UCS Tech Talk coming up in December. It's December 5th. We're going to talk about C-Series standalone servers. We're going to teach your old server some new tricks, and when you update your firmware for SIMC, and be able to get more out of it and managing those particular rack mount servers. Again, I'm sorry when it went over a couple minutes, but I really thank you for joining our Tech Talk series. I thank Jeff, I thank Jason for being my panelists today. If you have further comments, questions, please go to communities.cisco.com/UCS or communities.cisco.com/UCS integrations to get more information about UCS or our integrations. Ask questions, we'll answer them for you. Again, please go to communities and keep this discussion going. Thank you guys very much.
Thank you.
Thank you.